Namaskar friends, welcome to Electronics Technology channel. Topic of electronics technology news is digital arms race, the code and consequences of state-sponsored malware. Detailed analysis of Stuxnet, blueprint for physical damage. The sophisticated Stuxnet malware campaign targeting Iranian nuclear enrichment facilities represents a historic inflection point as one of the first confirmed instances of state-sponsored cyber sabotage aimed at destroying physical infrastructure. Discovered in 2010 after targeting Iranian operations for years, the Stuxnet campaign was likely a collaboration between the US and Israeli intelligence agencies, according to most expert analysis. It remains a case study of how, given sufficient resources and engineering capability, malware can be tailored to discreetly sabotage even highly sensitive isolated networks and physical equipment. The designers of Stuxnet leveraged an ingenious multivectored approach to infiltrate and compromise isolated systems at Iranian nuclear fuel enrichment facilities. Despite the Natanz facility housing critical centrifuges having no external internet connectivity, Stuxnet's developers prepared for penetrative reconnaissance and delivery of the payload through compromised third-party companies and removable media. By infiltrating the supply chain and networks of affiliated organizations, the malware operators identified vulnerabilities that allowed cracks in Natanz physical security via unvetted USB flash drives. Once the Stuxnet payload was deployed inside the air-gapped Natanz networks, the malware demonstrated sophisticated technical acumen to disguise itself using a Windows rootkit, injecting rogue code into the base operating system while intercepting and modifying API calls to cloak its presence. The Windows rootkit component leveraged stolen digital certificates to disguise Stuxnet as legitimate software. Meanwhile, the malware utilized additional zero-day local privilege escalation exploits in the Windows kernel to gain extensive administrative powers stealthily. Through this advanced infiltration and cloaking, the Stuxnet payload gained the trust and permissions necessary to reach its target, the Siemens Programmable Logic Controllers, PLCs, running the centrifuges. By compromising and reprogramming the PLC devices, Stuxnet's operators orchestrated a clever sabotage campaign that manipulated centrifuge spin cycles over weeks to gradually damage devices without activating obvious failure alerts. The malware essentially acted as a man in the middle, intercepting communications between centrifuge sensors and monitoring systems, filtering and modifying centrifuge status data reported to deceive operators, while also periodically issuing damaging commands to attached frequency converter drives for forcing unexpected rotational speed changes. This surgical sabotage targeting industrial control systems represents an entirely novel capability demonstrating cyberspace's merging with kinetic impact strategies. Stuxnet's pioneering digital sabotage advances opened the door to an era where malware could have tangible physical destruction effects. Its ripples permanently altered the nature of cyber warfare. The Stuxnet campaign had a substantial real-world impact by setting back Iran's nuclear enrichment program significantly. It destroyed an estimated 1,000 centrifuges and disrupted production for months. This highlighted the potency of cyber attacks on physical infrastructure to hostile powers worldwide. However, it avoided crossing into overt warfare territory by minimizing widespread damage. The lack of attribution and uncertainty around cumulative impact restrained armed response. Stuxnet remains uniquely dangerous as a blueprint of unmilitarized but highly impactful sabotage through sophisticated malware. Do you like this video? Please subscribe, share, like and press bell icon for getting notifications of my electronics technology channel, and for searching my channel please write at the rate electronics technology 50.